Hi, good evening to everyone. So for project 3, we have did the Game of Life game. So in this, the project manager is Joanna Tavera and Rachel Pars, myself, Ramadas Madhuri, and Justin Debrans. So let's see what is Game of Life. So Game of Life is the best known two-dimensional cellular automation, which is invented by John H. Conway and popularized in Martin Gardner's Scientific American column starting in October 1970. So Game of Life was originally played, that is like the successive generation were produced by hand with counters. But implementation on the computer greatly increased the ease of the exploring pattern. So Game of Life has like the two, it's like a two grid game. And the life cellular automation is placed by a number of filled cells on the two-dimensional grid. Each generation then switches the cell on or off depending on the state of the cell that surrounds it. So this is what the Game of Life is. So now we can look at what are the rules of the Game of Life. So basically we have some rules. First one is like birth. So what is birth? If the current cell is off and the count is exactly 3, then the current cell is switched off, something like that. So that's the birth. And we have death, obviously. So if a count is less than 2 or greater than 3, the current cell is switched off. So that is like death. And we also have like a survival. So if, for example, let's say, if we have a count, which is exactly 2, and we have like a B count, which is exactly 3, and the cell is on. The current cell is left uncharged. That is survival. And we also have the enemies by conjunction, which is like each live cell with at least 4 live neighbor will pass or in the future. So it's basically just depend on the life. That's how the game is actually played. So these are like the significant rules which we have to follow for playing this game. And next, let's see the UML diagram for this project. So the first, obviously the game home. So sorry that the UML diagram looks really crooked, but because it's really big, so we try to just put it in. So I'll explain it here. So let's say we have like the game home. So first we created the sign up page where we have to sign up if we are not already a user, or we also have like the login if we already have a user. So we just go to the login. So once that once we did these two processes, we will just submit, and that we will go into the Game of Life. And that is like the HTML page which we created, which has like obviously which will have username, password, and sessions. The session will start from there, and then the game starts, which is like the JavaScript. So we have did lot of we made array, and we did row count, call count, and we did 2D array because we have to do the two-dimensional grid. So these are some of the examples of UML diagram. This is how we did it. And then let's see the codes. So this is the game.javascript. So in this, if you see, we have we have row count, call count, which like initialize how many rows and columns we have to display when the Game of Life HTML loads. So that's the game, like when the game loads. And we also have like the circles, how it runs, like it will run and how many to run. And also the cycle will initialize the generations. So these are that. And we also make the functions to make the 2D array, and grid will set up all the values in 0 and return the array. So this function is like make 2D array function. And next function logGrid is to test the grid, which is loaded in again a Game of Life HTML. Make sure that it is just for to make sure it runs correctly, and it will not display anything else which is not correct. Oh, I'm sorry. So now next we have this again, this is like the JavaScript. So this basically explains that the status of the immediate 8 neighbors, because we have like the neighboring cells, right? around the cell without it being dependent on the previous cell checked, because the cell being checked is not independent on the previous cell. So that's what this we basically did. Yeah, that's what we basically did in this. And next one is like this is like the random grid we created, which creates the random pattern, which when you generate when you reload the game each time. So we like, you know, we have used like the math.random, and we also produced a random number to generate both the columns and row that will activate a dead cell somewhere on the board. So this process, you know, it will allow like let's say 1,000 times, allow the grid board to fill up quite a bit, and you know, when the process runs, it visually it looks really stunning. You know that I mean, we can see that more in the demo. And the next one is CSS. So we have designed this game.css, which is like very important. That have the features we have included. So the width is like, you know, 110 pixel. We have the padding, margin, border, box sizing, text align, and text transformations. So we have also given like the sleek buttons that are transparent with only a border around them. And also this design gives our game a modern edge without distracting the users from the game's main features. Okay. And then now let's see about, yeah, so the next part of game.css. So here we have given the striking background of our game, which is like produced, which uses this game.css, and we are given a div container, which is like .bg. To achieve this design, we have implemented the use of box shadow, which is here. Oh, I'm sorry. Yeah, box shadow, which is here, and inset allowed us to control control the shadows, which ultimately produced by the magnificent glowing ORB that surrounds the grid. And this design put emphasis on the game grid, so that the drawing the users into the focus on the reproduction destructions of the cells as generation come and go. So basically we have used this .bg for our background, and also to avoid shadows. And next is a test case. So usually this took us quite a long time, but yeah, so basically when you give the sign up and username, it will give us like, you know, uh, let's say the password, let's say the username is username and the password is hello, it will sign up. And with the login, when you go to login, we have to give the same username and same password, so that it will direct to the gameoflife.php. So in this game life PHP generation per run default 23. So then we have to like hit run button so that it will run. And we also have like the hit clear button generation per default 45. And we also have the patterns, so that each patterns you click, it will run accordingly. And finally, we also given the hit clear button, which clears all the pattern. And we'll also have a different patterns like, you know, let's say for generation per run default 23, and planet blink, like pattern blinker, and then it run button. So these are the test cases which we did, and this will be mostly discussed in the demo. And next, this is how the screenshot of our game looks like. So first is the welcome to the game of the life, and we have like the returning users and new users, which is like, you know, which when we already have the login, we can use this, and new user can use this. So login will be like this, and login and correct info continue to game. If when after we go to the game will be like this. So when we start playing this game, and then we have these options to use, like whatever generation per run, and we also have the four patterns: glider, loaf, blinker, and random. So these are these are our game looks like. And yeah, so basically this is the credit, and this is how we did this whole project, and I hope everyone liked it. And also important thing, the demo will be performed by Rachel. So yeah, continue to watch that. Thank you, and I hope you guys really enjoyed it.
To our Game of Life. This is part 2 of our presentation. This is our demo. Our beginning page is our game home, where we have two options. We have an option for returning users, meaning that they have played our game before and their information is in our database. And we also have an option for new users. So I'll go ahead and demonstrate our new user button. So go ahead and click new user, and I will be redirected to our new user sign up. So I'm going to go ahead and enter in some user information and try to sign up. All right, so it is now redirecting me to the login page, meaning that I have officially signed up and I am ready to log in. We do have a back to home page button. I'm not going to click that, but that button will redirect you back to the main game home, where we had the returning users and new users options. So I'm going to go ahead and attempt to log in with my user password. And it says not now. So it says invalid user or password. So I just intentionally used a wrong password for my username from Hank. And I'm going to now enter in hopefully the correct password. And huzzah, we have authenticated our username and password. So the correct info, continue the game. So I'll go ahead and click that. And here we go. So we are now officially at our game page, the game of life. And you can see that our user information was passed. You can see the user, and my username is Hank. We implemented that through use of PHP and Post. So here you'll see this is our game grid. We do have some fantastic CSC implementation design that you've seen on the previous pages. To make it cohesive, we just stuck with the same background for all of our pages. So we do have a generations per run option. It was a requirement that we had two options where we can run 23 generations, or we can run one. We do have the step button, and the step button does, as you can see, it moves it one generation at a time. So we do have both those requirements. A fun thing about our generations per run is that we can actually change it to 50. So I could run it and we could see that it's going 50 times, and this particular pattern that you see if it's moved is our glider option. So that's the first one that auto-populates. Another attention to detail. Another thing I would like to bring to your attention is the detail of our generations. So I individually clicked step 5 times, and then I clicked run on the 50. So if I go ahead and click more, you can see that the generation button is iterating up. So it keeps up with all of the generations that you end up doing. No matter how many times you step or click run again, it's going to continue. So press stop. And so pressing our stop button is a way to put a pause on the generation. And we also do have the clear option, so that will clear our generations in total and clear the board. We do have the loaf option, loaf pattern. And now this pattern is non-moving. It is a still pattern. I believe that stills are used as a way to add a buffer in when you have a lot more pattern on the board. We also do have the blinker, which is very fun. That'll expand out and go. And then we do have a random pattern button. And this has been implemented through the use of a for loop. It is being iterated over, I think at 1,000 times the for loop is executed. And we're using Mathfloor and MathRandom. And we're multiplying that by 50 for each the row in the columns. so that we can generate all of these pixels. And so when I press run, you'll get a lot more movement on the board, and through all of the generations, you'll actually get to see some patterns that we already have. We've already have been seen on our end, such as like the glider, the loaf, the blinker. They'll all eventually kind of turn into some of those symbols. Like we have kind of like the blinker right here, and you'll see eventually you'll get, I forget what this is called, but there's a still life pattern as well. Yeah, so we have all the core requirements. We have stop, start, run, our patterns. Pretty fun game. Once we start implementing all the patterns, I will go ahead and add the link to our game in the comment section below in our YouTube channel. I urge you all to give it a try. It's pretty fun, great visuals, and we appreciate you watching our presentation, and we hope you have fun playing our game. Thanks.